Now we have wall detection working. We can see when we're up against a wall, but we still get stuck and we don't use it. So before we go on to the solution, I want to do this as a challenge and give you the opportunity to take a look at what we've done, take a look at our two new parameters and maybe our update movement method, and see if you can figure out how to stop the player from running up against walls or sliding down against walls and kind of holding themselves up against them. So go ahead and take a look, see if you can figure it out. You could do it in as little as 4 lines of code, maybe even less, and it should be a relatively simple one. If you get stuck though, don't worry, we're going to go through the solution in just a second. So go ahead now and give it a try. All right, I'll assume that you've either done it, had lots of success, or maybe got a little bit stuck and had a question or two, and we're going to go through the solution right now. So let's open up our player script, and inside of our update movement method, right here, we're going to do a check right down at the bottom. Before we set the velocity of our character, we're going to check to make sure that we're not trying to push up against a wall. If we are, then we just won't modify our horizontal, or we'll set our horizontal to 0 to stop ourselves from moving. To do that, we'll add in a couple lines right here on 191. We'll say if our desired horizontal is greater than 0, so if we're going to the right, and is touching right wall, then our velocity, or our horizontal, not our velocity, is equal to 0. Now, it will also want to do the same for the left, so I'll just copy this, hit enter, and then do a check for negative or less than 0. So if desired horizontal is less than 0, meaning we're going to the left, and is touching the left wall is true, then horizontal will also be set to 0. Now if I save, go back into Unity and press play, I should see that I've got nice smooth movement with my character, and I can no longer get stuck on those walls, and I should actually stop running when I push up against it. Let's see if that's the case. So I run over here, my character stops trying to run, and if I run or jump and slide down these edges, you see that I can no longer get stuck and act weird, which is going to be perfect for our bee encounter. So once we get over here to start fighting the bee, well, this is where we'll see that our raycast actually needs to be slightly smarter. Remember, we used a very basic raycast, and it's checking against this trigger and thinking that we're touching a wall right there. In fact, when we're in the water, it thinks that we're touching walls on the right and left. So we've refactored this code and split it up enough that it should be an easy one for you to fix. So challenge number 2, go fix that. Go find the problem, see if you can figure out why it's getting stuck, and if you can figure out the solution. It's in the raycast. It should be pretty straightforward, but if you get stuck, don't worry. We're going to go through the solution in 1 second. All right, back to it. Let's go through the solution for our raycast. So when we check if we're touching a wall, let's go find the code for wall touching. Update wall touching right here in our check for wall method. When we do this check, we're just doing a basic raycast right here on line 115. Now this has 2 problems. 1, it checks triggers, which we don't want it to do. And 2, it only checks 1 object. So if the first thing that we found was a trigger and then we had another collider there, then we could end up in a scenario where we're up against a wall, but we don't know it. So we need to make a quick couple changes to our raycast. Let's go find the part where we do our grounding. In our grounding, if we check our check grounding method, remember we call raycast with the results, where we pass in an array and then we fill it up and then we get back a number of hits. Let's copy that, lines 222 through 226. And then we'll go back into our raycast here, and instead of just doing 1 raycast, we'll raycast against all of the objects. I'm going to tab this over here, and then we'll use the direction instead of vector2.down. And then for our layer mask, I think we can use that same layer mask and we can use the same result. Now I'm going to delete lines 120 and 121, and instead we're going to loop through all of our results. So we'll do another for loop, and we'll loop through to the count of hits. And notice that I'm reusing results here. That's totally fine. These aren't running at the same time. Results will get cleared out and reused. It's totally fine to reuse it for these objects as long as I don't have to worry about them happening simultaneously. So here we've got an issue where it doesn't like my loop inside of a loop because the variable name is the same. So we're going to rename I to the next letter in the alphabet, which is J. So we'll loop through J hits and we'll check to see if any of the objects that we hit are not a trigger. If they're not a trigger, then we'll return true. So we'll say if, and we want here our results at I dot collider is not equal to null. So we'll do question mark dot is trigger equals false, double equals false. So what that's going to do is double check that there is a collider there is true and the is trigger is there and that's equal to false. If that's the case, then we'll return true. I don't like that this is a little bit confusing to read though, so I'm going to just rewrite this. Let's say var hit equals underscore results at I, and then we'll say if hit dot collider and hit dot is trigger or hit dot collider dot is trigger is equal to false, then we'll return true. Again, does exactly the same thing. I just feel like this is a little bit easier for me to read and catch that I used results I here instead of J. Exactly the kind of thing why I want to split this out. In fact, let's call this hit index. And I like that even better so that I don't have to worry about accidentally using the wrong variable there. All right, so now we're looping through all of them and only checking colliders.